Para-aminophenol or 4-aminophenol is basically a benzene ring with an OH and NH2 group in opposite sides. The main use of para-aminophenol is as a building block, but it also has some industrial applications, such as a film developer, like this one for example. But as I said, para-aminophenol is more used for chemical synthesis. You can synthesize paracetamol or mesalazine, but pharmaceutical products. Also, para-aminophenol is a primary aromatic amine, so you can basically synthesize laconium salts using sodium nitrite acidic conditions at low temperatures. And these laconium salts are useful for the Sand-Mayer reaction. By diazotization of para-aminophenol, you can get para-bromophenol, para-chlorophenol, para-iodophenols, hydroquinone, para-fluorophenol, and even phenol itself, just for mention some. So, naturally, the question is, how do we get para-aminophenol? The first way is the direct nitration of phenol, and then the reduction to para-aminophenol. The problem with this synthesis is that you will also get the orthoisomer, and this is just too hard working for getting moderate to low yields. Other way is from nitrobenzene. Zinc over aqueous ammonium chloride reduces nitrobenzene to N-phenyl hydroxylamine, and this compound, using the Bamberger rearrangement, is converted into para-aminophenol. This reaction looks quite interesting. I may be doing it in the future. But today, I'm not going to do neither of them. I'm going to extract the paracetamol using the exact same method I mentioned in a previous video, and then I'm going to hydrolyze it using hydrochloric acid and microwaves. For this experiment, you will need hydrochloric acid, a lot of paracetamol, distilled water, sodium bicarbonate, and methanol. The first step is to add the tablets into a beaker. I got 59 tablets of 500 milligrams each, corresponding to a total mass of 29.5 grams of paracetamol. Put the tablets in an adequate round bottom flask. In it must fit all the methanol. In my case, it was 455 mils. I started moving and chopping the tablets with a glass stirring rod. And after some minutes, with a stir bar. I then set up things into reflux. But watch out, please do not fill as much as I did the round bottom flask, because this could happen. After adjusting the temperature, I got a nice and gentle boil. I keep the reflux for 1 hour and then I let it cool. The next thing to do is to get rid of the excipient and bacle present in the tablets. So I'm going to filter off the solution. Here you can see all the excipient. And that's it. We have a methanol solution containing almost pure paracetamol. Then we have to remove the methanol out of the paracetamol. So I decided to distill it off. After 30 minutes, the methanol started coming out. And eventually I got removed all the methanol. So there you go. We have here approximately 29 grams of paracetamol. I don't find necessary to weigh it out, because we are going to use it in another step anyway. So I immediately continued with the synthesis. I added 100 milliliters of hydrochloric acid at 28%, which represents a very high excess. more than 3 times. As you can see, paracetamol is quite insoluble in water. For starting up the reaction, we are going to microwave the mixture in a total of 12 sets of 10 seconds each. Then I set up the reflux apparatus with a sodium hydroxide trap for acidic fumes, as you can see. While this is reacting, let's discuss the mechanism. The first step is the donation of an electron pair from nitrogen in order to get the oxygen protonated. This intermediate is formed and then water attacks the electrophilic carbon, breaking the pi bond into the nitrogen atom. This intermediate takes place and a proton transfer occurs. Then the oxygen atom forms a double carbon-oxygen bond, kicking away p-aminophenol and forming the protonated form of acetic acid. And for the last step, the amino group takes the proton of the protonated form of acetic acid or from hydrochloric acid, forming our p-aminophenol hydrochloride product. After an hour and a half of reflux, the p-aminophenol hydrochloride started precipitating very conveniently. And then we are going to filter it under vacuum. I then transfer all this solid into a crystallization dish. I rinse the flask using the same filtrate. Do not use distilled water to rinse this product because it will dissolve very easily. I mix the two solids and weigh them. I basically created matter. Nah, the product is just wet, so I'm going to dry it out. I heat it for 40 minutes to 80 degrees Celsius. But it wasn't enough. I decided to use aluminum foil in order to get a large area, but please don't do this was a mistake. The sample still contains hydrochloric acid, which reacts with aluminum. The good thing is that I know this early, but this definitely hurt my yield. I dry it for 2 hours at 90 degrees Celsius, and I got a very dry product at the end. I was able to collect 22.14 grams of p-aminophenol hydrochloride. I wanted to get as much p-aminophenol as possible, so I'm going to extract the p-aminophenol that remained dissolved on the filtrate. I started adding sodium bicarbonate till the pH was between 7 or 8. P-aminophenol has 2 pKa's. The first one is at 5.48. It means in pHs below that, p-aminophenol will be protonated on the amino group, and other pKa in 10.17. It means in pHs superior than this, it will be deprotonated on the phenol group. After reaching a pH of approximately 7, p-aminophenol in its free base form started precipitating, so I filtrated it out. I didn't want my product to be contaminated with sodium bicarbonate, so I made a test. I took a small quantity in a flask and added hydrochloric acid to see any effervescence, which indeed happened, so the product is contaminated with sodium bicarbonate. I rinsed the product with some acidified water to get rid of all the sodium bicarbonate present. It kind of worked. I filtered and dried it a lot of times, and I was able to recover in total 3 grams of product. The both solids combined corresponds to a yield of 88.5%. Pretty decent in my opinion. As a fun fact, the solutions containing p-aminophenol got dark in no time. This is because p-aminophenol is very unstable on alkaline and neutral solutions. To finish the experiment, I made a TLC of the two solids and paracetamol. As you can see, The two solids have the same retention time, and paracetamol is a little bit higher than that. And that's it. Thank you for watching, please subscribe, and see you soon in the next video.